Hey, it's me. Oh, I thought I'd have some fun with this one. Uh, my daughter showed me the snap filter on the webcam, so we'll have a little bit of fun here with this one. All right, so we are going to be looking at an illustrative example of how to compute the projected benefit obligation. All right. I don't know if I'm going to be able to make it through this. All right. All right. Computing the projected benefit obligation, or the PBO, as we potatoes like to call it. So here's a timeline. Okay, I'm going to throw a bunch of information at you. I'd highly recommend that you actually print this slide out so you have it in front of you as you go through the video, because it's a lot of information and there's going to be some present value calculations. And then I'll kind of back up and see what it all means. But here's a timeline with 56 years. Yeah, 56 years. So let's get started. What are we talking about? Well, let's take some given information. Let's assume that at the beginning of year one, a company hires a new employee at a starting salary of $31,575.36. That's oddly specific, but you'll see why in a second. The company also provides this employee with a defined benefit retirement plan, a pension. I can't stop looking at the stupid potato on the corner. All right. Which will pay the employee an annual income throughout retirement based on the following formula. They'll get 2% of the product of the number of years worked prior to retiring times the salary level at retirement. So their current salary at the beginning of year one when they're hired is $31,575.36, which is pretty much what I started out working as an engineer, oddly enough. Okay, so that's kind of the deal. So they're not only working for salary, they're also working for future benefits that they're going to earn by working for this company. So what's next? Well, the company, because this is a defined benefit plan, has to go out and estimate a pension obligation or the projected benefit obligation, because that's the liability that the company is going to have to recognize with respect to this pension that they're giving their employee. So they go out and hire an actuary who's going to come up with some of the necessary inputs for computing that PBO. Let's see what he has to say. So the actuary comes and says, we estimate that employee that you just hired is going to work for you for 40 years and then retire at the end of year 40. In addition, we estimate, given this salary, this type of employee and other comparable statistics or rates of increase, we believe that this employee's salary is going to increase on average at a rate of 3% per year, which means that if you roll that forward to year 40, they will exactly have a salary at retirement of $100,000. Now you know why I put the 31,575.36, because it conveniently works out to be $100,000, a nice round number. Again, we're going to need, let me get my little potato pen here. Yeah. Oh no, it's not running to write. There, we need that salary. Oh, we're already on to the next. The actuary is anxious to get started. So the employee will receive an annual pension payment for exactly 15 years. In other words, they'll compute the annual pension payment based on the formula above, and whatever that number is, the employee will receive that amount of income each year for 15 years, and then in year 55, they turn into French fries. They permanently retire or they expire. Oh my gosh, I'm having too much fun here. All right. All right. All right. So that's kind of the setting. And the actuary also comes out and says, you know, for this type of obligation and the risk associated with it and the employee's tolerance for bearing that risk, we think that the applicable discount rate is going to be 7%. That's the discount rate you'll apply to estimate the present value of that obligation. So our objective here is to look at, compute, or not look at, just compute, what is the projected benefit obligation at the end of year 1 and at the end of year 2. The PBO at the beginning of year 1 or at the hire date is 0, because technically the employee hasn't had any years of service at that point, so anything times 0 is 0. So that's what we're going to do. I'm going to walk you through how we would calculate it, primarily for year 1. So what is the PBO at the end of the first year? What's the future obligation based on the definition of projected benefit obligation that we talked about earlier? And then we will apply the same logic to year 2, which it should be relatively straightforward, because then we can just roll it forward and calculate this PBO each year up until year 40 when they retire. And we can kind of look at that and start to see that, yes, these obligations build up. That's the plan. Let's get going. All right, let me move over here. Yeah, let me move out of the way a little. Yeah. Okay, so we want to compute the projected benefit obligation at the beginning of year 1, or at the end of year 1. Once the employee has put in 1 whole year of service, they have been flipping French fries for an entire year. So the question is, what is their benefit that they've earned after 1 whole year? So creepy. Okay. So recall, to calculate the projected benefit obligation, we need to use the company's formula that they use to determine what the future cash flow payments are going to be. But recall that the projected benefit obligation is actually going to be based on the current number of years of service to date, which in this case is 1, and not the current salary level, which is about 30-some thousand, but the projected salary at retirement, which is always going to be 100,000. So here we go. We're going to take 2%, according to the formula, times the current number of years of service, which at this point is 1 whole year. Then we are going to take the projected salary, which we determined was going to be 100,000. That's compounding it at 3%. And that conveniently gives us, as of the first year, this employee is going to receive $2,000 per year, not total, but per year when they retire. If they were to retire today, they would get $2,000 per year for the rest of their life from this company, which isn't much. Okay, so that means because the employee is going to live for 15 years after they retire in year 40, they're going to receive $2,000 15 times until year 55, where expiration. Oh, I can't stop staring at the potato. Okay, so all we have to do is discount back those future cash flows to compute the projected benefit obligation. So let's take the first one. It's just going to be the sum of the present values of all 15. You can use an Excel formula. You can do whatever you want. I'm just trying to show you the math here, just for the sake of completion. But if you want to use any kind of built-in formula, have at it. So you're going to receive a $2,000 cash flow at the end of year 41, which means relative to the end of year 1, that's 40 years. You have to discount it back. 40 whole years. which is why we're discounting it back 40 years. So that's the first cash flow payment. And again, we're getting $2,000 per year. Then we move on to the second one. And in this case, that is the same cash flow, but it's 1 year further removed, which means we're discounting it back one additional period, or 41. And we do that for all 15. This is the 14th one. You're discounting that back 53. And finally, the 15th one, discounting it back 54 years. And then your baked potato. And then the projected benefit obligation at the end of year one for this employee, for that company, this company will have to report a liability of $1,302, up from $0 at the beginning of the year. Let's take a look at year two. Ooh. So in year two, we're now plugging in 2 years of service, which means that the employee after 2 years is entitled to twice the amount of cash flows, or 1 additional year's worth of cash flows. But when present valuing it, the present value is not exactly double. Instead, it's more than double, $2,785, because we're 1 year closer to retirement, and so all of the discounting is coming closer to us in time, which means the present value is going to go up, all else equal. So in this case, it's increasing because we increased the nominal cash flow payments in retirement, the $4,000, and then we are discounting it back 1 year less because we're 1 year closer to retirement, and so we get $2,785. This is what the company will do every year that this employee works for them until they retire. And so let's see what that looks like graphically. Not that interesting. This is the 2,700 that we just calculated, and this is the 1,300 that we calculated in year one. So the company, this is the employee's projected benefit obligation at the end of each year. Let's get serious. Okay, let's do year three. I'm not going to walk you through the calculations. I'm sure you can build a spreadsheet that does it much easier. So you can see that the obligation continues to go up. Let's just let her rip for the next 37 years and see what the pension obligation would be in year 40. Ooh, very pretty. Very pretty. Wait, something's not right here. Why has it disappeared? I can't see what that value is. Hold on. Why is that value so? What happened? Let me go back a little. Wait. $750,000. Yikes. This employee who had a small benefit earned of $1,300 at the end of year one, after 40 years time, is up. The obligation to that employee at retirement for that company is $750,000. That's a big obligation. Why did we get into that? Remember, each year the employee is earning 1 additional year's worth of service, so their cash flows are going up that they're getting. It's going up by $2,000 for each additional year that they're working, and that starts to get expensive. But the real cost comes in the fact that technically you're not paying these employees for anything. You're promising them, so they've lent you their value by working for you, but you're not paying them cash. So that 7% discount rate is implicitly charging them interest. And every year it's 7% of a larger and larger balance, which is why these things exponentially explode out of control. In other words, this large value in the future is effectively what we have today in the form of, if I can get this to go on, yep, there. I overshot it. Ooh, it's not going to let me go back. Okay, I'm back. Still won't go back, but we'll just go with it anyways. The graph behind there is, that's just simply that graph of all the top 20 PBOs in the country. In other words, we're there today simply because these things grow out of control, especially when firms aren't supposed to write them down. And so measuring the plan obligations, such as the PBO for this illustrative example, obviously requires a lot of assumptions about things like life expectancy, employee turnover rates, rates of salary increases, and discount rates. And just subtle changes to those can shoot that liability all over the map, which means that typically equity has to go up with a gain or loss on the income statement, which means that because of the discretionary nature of these, I mean, life expectancy proves the actuary wrong. It's going to take you 50 years to prove them wrong. Things like employee turnover rates, rates of salary increases. These are all estimates plus or minus 10 times that estimate. So companies have to disclose in their footnotes some sort of high-level aggregated assumptions. It's not going to be sufficient to allow you to determine the exact, do those exact calculations that I just did. I only do those calculations to show you how the potatoes are made. Sorry. Oh, where was I? Okay. The aggregate assumptions, they have to be disclosed in the footnotes to the financial statements. Here is the example of Pfizer's. The only thing you can do with these is really just see if it passes the smell test of, is 4% a reasonable discount rate to apply to these? If I saw 70%, I would probably say no. Is the rate of compensation increase 2.8% reasonable? I'd have to dig in to see what kind of employees are covered by that. And then what you're really looking for are changes throughout the year. If you see like a massive change, especially when it benefits the company by reducing the liability, which has to increase equity by recognizing a gain, then you can start to ask more questions. But in general, if companies are going to mess around with these assumptions, because they have to be verified by an actuary, if they're going to mess around with it, they're not going to go and just crank one of the assumptions up. They're just going to change all the assumptions just ever so slightly, so every individual assumption falls within a reasonable boundary. And so just be aware that companies have to disclose these actuarial assumptions. But again, these are covering 4 different categories of pension plans. And within each category, U.S. qualified, U.S. supplemental, international, and post-retirement plans, Pfizer probably has hundreds, if not thousands, of different pension plans in there. This is very aggregated and really won't let you do the exact calculations. So that's it. I'm out of here. Professor Ball will be back. I should do the whole course like this. I mean, talk about being annoyed with me. You'd be really annoyed at that point. Potato out.